So in this video, I want to talk about some things to do with functions. So functions, just a quick reminder, are mappings from a set which we call the domain. This one can be the domain to another set. If this function is called f, and we'll label that there, to another set called the range. This is the range. So in particular, maybe we have some points here and some points here, and f will send this point to this point maybe, and it will send this point also to this point, it'll send this point to here, etc. Okay, so this is what we mean by a function. And now we're going to define a couple of important terms. So to start with, we're going to talk about an injective function. And then we'll talk about a surjective function. So these are two really important properties of functions. So injective and surjective functions are really important functions often. So an injective function would look something like this. So what color should we use? We'll use yellow. So again, we've got our domain and our range. And an injective function is where no two things from the domain hit the same thing in the range. So for instance, if we had, in the top here, we see that both of these points hit that point there in the range. And so this is not injective. I'll just label that. So this here shows that it's not injective because we have 2 points in the domain which hit the same point in the range. Okay, I'll give a more formal, in fact, I'll write down a more formal definition now. So here, if we go, f is injective if the following holds. So f of x equals f of y implies x equals y. Okay, this is what it means to be injective. It means if we take two elements in the domain, x and y, apply f to them and get the same thing, then we know that x must have been equal to y. Okay, they couldn't have been different, because then we'd have a situation like this here, which we said was not injective. Okay, and so an injective function would look something like this. Maybe we have another point here and that one round there. Note there's still a point in the range here that hasn't been hit. Okay, so because of that, this f, I'll leave this f again, I'll leave this g, this function g is not surjective because there's a point in the range which it hasn't hit. Okay, so equally this isn't surjective because there are points in the range here that haven't been hit. Okay, so an example of a surjective function could be for example, this maybe, if you have all of these going to this one point in the range, then all of the points in the range have been hit. Okay, so this isn't injective because there are three things going to the same, three distinct elements of the domain going to an identical element of the range, so it's not injective, but it is surjective because all of the elements in the range have been hit. Okay, so again, we'll do a more formal definition. F is surjective, or sometimes it's referred to as onto, if for all y in the range there's an x in the domain such that f of x equals y. So what this says is, if you give me anything in the range, then I can find you an element of the domain such that when you apply f to it, you get y, okay? i.e., this is the picture you want to have. Everything is being hit, whereas here is not surjective because this element, for example, is not being hit. So this is surjective, and the Euler function g, call this h. So h is surjective, g is not surjective. So I'll give you some more concrete examples now of actual functions which have these properties. So, for instance, if we consider f of x is x squared, where our domain, just undo that, domain is all real numbers, and our range is also all real numbers, then, well, is f surjective or injective? So to test for injectivity, remember this is the picture that we have, which is each element of the range is hit by no more than one element of the domain. Okay. So is f injective? Well, no, because for example, f of 2 is 4, but that's also f of minus 2, and 2 doesn't equal minus 2. And so we have two distinct elements of our domain, 2 and minus 2 are both in R, such that when you apply f to them, you get 4 in both cases. Okay, so f is not injective. Not injective. And is it surjective? Well, I don't think that you can hit minus 1, for example. So x squared equals minus 1 has no solutions in R. When I say in R, that means with the domain being R, therefore not surjective. However, what we can do is we can mess with the domain and range. Okay, so if instead we defined the domain, we keep this the function definition the same and change the domain and range, then we can make it injective or surjective. So for example, if our domain is the positive reals, okay, then I think you can see that f is injective because we're not going to have this issue where a number squared is the same as its minus squared. So I think this is fairly intuitive to see that this is injective. Or if we had the range as R plus, with the domain as R plus or R, then f is surjective because x squared equals y has solutions for any y bigger than 0. Okay, so all the elements in our range can be hit by some x. Okay, and so this is surjective. And now finally, just like a quick definition, and then I think I'll do the next. I'll carry on in a second video and talk about inverses. But just to finish, a function is bijective if it's both injective, and surjective. And then we have the following picture, which is that everything in the domain is mapped to a distinct thing in the range. So the sizes of the sets must also be the same. You must have the same cardinality in the left and the right. A more precise way to say that would be. So every element in the range is hit by something in the domain, and no two things in the domain hit the same thing. Okay, so this is bijective. Okay, I hope that was useful, and I'll do the next one on inverses.